Welcome. In this session in linear data analysis, we'll explore some of the concepts that surround clustering. So we'll deal with data vectors that are all real numbers and they have m entries, and all of the data vectors that we examine have to have this same size. And we'll look at a cluster in two ways. The first is we'll say that they are just sets that have certain data vectors as members. An alternative is that we can define a cluster as a centroid, and a centroid is an extension of the idea of an average vector or a mean vector. And we would say that a cluster, for example, is a centroid and perhaps it's the neighbors within a certain radius, or it may be all of those data vectors that are closer to this centroid than they are to another centroid. So the problem is, how do we define a cluster? We'll mainly work with this second definition, but this first definition will be important when we go to do computations. There are two methods that we can deal with. One is to simply treat all of the data vectors uniformly. An alternative is that we might take the data and we might do a first clustering of the data. For example, it might be into 2 or 3 clusters. And then for each one of those clusters, we could find subclusters. And that means that we would have a hierarchical clustering method, and this allows us to have deep subsets. And it also allows us to structure our data in ways that we can't if we're treating all of the vectors uniformly. So to do this, we're going to rely on the idea of a distance or a norm over vectors. So one norm that we'll often use is the L2 or Euclidean norm, and that's the square root of the sum of the squares, or for clustering purposes, we often deal with just the square of the norm. So with this, we'll associate a mean with a cluster. And we'll write this mean as the vector g, and when we need to, we'll index it with the letter I. So we now have two options. One is we can define this mean or centroid in terms of the cluster, and that would be a computation. We would take all of the vectors that are indicated as having that index, and we would add them up and then divide by the number, and that would be the arithmetic mean. So this centroid would give us an idea of an average vector that's in the cluster. The alternative is we could define the cluster in terms of the mean. And what that would be is we would say that cluster number I is defined as all the vectors such that for every index L, the distance between the vector u and the centroid of the cluster that we're defining is less than or equal to the distance of the vector to any other. And here we put in a less than or equal so that we don't have to fuss over whether I equals L, etc. So these are two definitions, and when we go to do computations, what we'll end up doing is we'll be alternating between these two definitions of a cluster. So let's go through some visual examples. I randomly generated 200 vectors in a plane, and when I did it, they look like this. And it's easy for us to draw most of the two clusters. We do, however, have some questions about what to do with these two vectors. And in an automated clustering algorithm, what I computed was this. The algorithm assigned one of these vectors to the red cluster and one of these vectors to the blue cluster. And that was just the result of a computation, and if I repeat it many, many times, I keep getting basically the same result. Now, suppose I add another 100. Now, what we have is we have this original cluster, and then a second cluster, and now a third one. And we can see that it's now quite unclear, perhaps, how to assign these points, but because a cluster is a partition, every point that we have, every data vector, has to be assigned to one of the 3 clusters that we're going to have. And when I perform the automation, this is an example. So it's continued to assign all of the data vectors in the blue to the blue, and for the red, it's assigned most of them, but we're going to have to go through a little inspection of this zone, and now in the magenta or purplish color, we have the third cluster. So let's take a look at this region in a little more detail. what we have is this. Now let's observe in particular this vector. So this is currently assigned as red. And when I add 100 vectors and I say, now computer give me 3 clusters, what it does is it's turned this from the red into the magenta cluster. So it's reassigned it. And this is a behavior that we'll often see in clustering. So we have a couple of observations. Is that the first is that the number of clusters matters. And in this case, when I have these 300 vectors, if I said, computer, cluster this into 2, it would have clustered the red and the magenta into one cluster and then left this as a distinct cluster. So that's one observation. And then another observation we can make is that previous clustering can change with new data. And both of these are important observations that we have to keep in mind when we do machine learning of data or data analysis or data mining of some data that we're given.